Okay, you guys, I have a happy holidays present. Are you guys ready?
Yes.
So I was adding up numbers, which is the bane of my existence, but in preparing for a board meeting, 20 million acres has been committed for protected areas in the Y2Y region and this is the work of so many partners over 4 years. 20 million acres.
Wow.
Wow. Where is
So
the bulk of
done? Like 3 of those are the indigenous-led conservation efforts, like Katmuk and the Caribou Agreement and the Peel, and those will, they have to be legislated, but they're promised. It's so exciting.
That's amazing.
Quite something.
I know.
So is that the bulk of it, Jodie?
My yoga ball when I figured that out.
Is that the is the bulk from BC? Would you say?
Well, this one,
biggest, okay.
and Katmuk is a small one in BC, and then the Peace River Agreement is in BC too, and it's kind of medium. And then things like Castle, that was within 4 years, and then a few down in the States too. So
yeah. Nice. Yeah, that's quite impressive.
I was sort of feeling a little blue, and that cheered me up. So good to see that stuff happening.
Wow, that is amazing. All right, well, we are approaching the time.
And I really want that coffee that's being shown. Anybody else?
Hopefully you've got yours. I've got mine here. This might tea, but
I have my tea.
Yeah, we all got to be cozied up. But we have approached the top of the hour according to my computer. So let's jump into things. Thank you so much, everyone, for joining us for the Crown Managers Partnership webinar on ecological connectivity in the Crown. We're so excited to have you here with us today. My name is Natalie Prumba. I am the coordinator for the Crown Managers Partnership. And like we were saying before, hopefully you're cozied up with some tea, some coffee, and you're ready to learn from experts throughout the Crown with us. So a bit of housekeeping before we get started. The session is being recorded, just so you're aware, and the recording will be available on our website, and it will also be available in a follow-up email that I send out after the session. We ask that you keep your microphones muted on your phone and your computer, and also that you keep your video off unless you're speaking, and that will just help us with any bandwidth related issues. And also we encourage you to type any questions or comments that you might have into the chat at any point during the webinar. Each speaker will answer questions at the end of their presentation for about 10 minutes, and then any remaining time at the end of the webinar will be more time for Q&A. To use the chat function, you scroll your mouse either across the top or bottom of your screen, and you'll see a black bar that appears and icon with a speech bubble. It says chat. You'll click on chat, and then a new box will appear, and you'll type in your question there. And just so you're aware, the questions will come through me and not the entire group. So before we get to our speakers, I just wanted to place us in the context of the geography. So the Crown of the Continent ecosystem is nearly 18 million acres in size. It's home to some of North America's most iconic wildlife: wolverine, elk, bull trout, West Slope cutthroat trout, Canada lynx, grizzly bear. And in order to access the resources they need and maintain genetically diverse populations, these wildlife species require the ability to move freely through high quality connected habitats. And as most of you also know, the Crown is facing increased pressure from human activity, urban and rural residential expansion, increase in diversified recreation use, resource and extraction demands, and the physical infrastructure that is needed to support all of these things, and also climate change. So today we are going to learn from speakers who will share with us their insight on the places and the ways to conserve connectivity on the landscape in the face of these changes. So who and what to expect in the next hour. Unfortunately, Mike Derglo is unable to join us today, but we are really looking forward to rescheduling his presentation at a future webinar. And we're pleased to be able to give some extra time to the two speakers that we do have here with us today. So the first speaker is Tracy Lee, and Tracy is the Senior Project Manager for the Miistakis Institute. And she is going to talk to us today about prioritizing human safety and multi-species connectivity across a regional road network. And our second speaker is Jodie Hilty, and she is the Deputy Chair of the IUCN Connectivity Conservation Specialist Group, and she is the lead author of the guidelines, which she'll speak to us about today. And her day job is the President and Chief Scientist of the Yellowstone to Yukon Conservation Initiative. So without further ado, I am going to stop sharing my screen. I'm going to hand it over to Tracy, who is going to kick us off.
Can you see my screen? Sorry. That one.
No, I can't.
Okay. One moment, everybody. Thanks, Jodie. Okay, good morning, and nice to see you all here. I'm actually quite excited today to be able to talk to you guys about this project. The purpose, or what I'm going to talk to you about today, is how we developed a process in Alberta to try to help prioritize where road mitigation needs to occur, based not only on motorist safety, but also on ecological connectivity. And so we just had this paper published in Conservation Science and Practice, which was a really exciting thing for me. And I'd just like to acknowledge the co-authors, Tyler Creech, Adam Martinson, Scott Nielsen, Andrew Jakes, Paul Jones, Ken Sanderson, and Adam Ford. So the purpose of this project really stemmed from Miistakis and its partners' work down on Highway 3. And we have spent a lot of years researching Highway 3. We know that it's a barrier for certain species that avoid the highway. And we also know that there's a lot of collisions that occur on this highway. So we have the issue, and we have an ecological connectivity issue, as it's a barrier to movement. And we did a lot of research. We came up with where we thought mitigation needed to occur. We recommended what type of mitigation we thought needed to occur on this highway. And in our conversations, particularly with Alberta Transportation, it became really clear that even though we have a really good business case and they understand the need for this, how they need to make decisions is at the operational scale. And so they're actually making decisions at a provincial highway network scale. And so how does this little stretch of highway that we've studied in depth relate to that bigger provincial network? And so really what it became clear is that there needs to be a systematic way that we look at a state's highway network or a provincial highway network and help prioritize where mitigation should occur. So that was the impetus for this project. So our objectives were to have multi-departmental engagements. So both Alberta Transportation and Alberta Environment and Parks were involved in our process. And that's because they have different mandates that can both benefit from road mitigation. We sought to identify road sections, and by a road section, I'm talking about a kilometer section. So we sought to identify road sections that had high connectivity value. We wanted to identify road sections that were a high risk to motorist safety or where a high number of animal vehicle collisions were occurring. And we wanted to understand where those two conditions intersect. And then we wanted to be able to help government agencies prioritize road sections for mitigation, where mitigation should be considered. This is our study area. It's actually the South Saskatchewan planning region. We did not take on the whole province. We wanted to see if this method worked first. And I think you all know that most of you are on here are interested in the Crown, which was a portion of our study area. So the methodology that we undertook were to engage our stakeholders, which was a lot of government representatives and some of the NGOs that work in the region. We identified metrics that we felt addressed both motorist safety and ecological connectivity, so a series of metrics, which I'm going to show you in a minute. We developed connectivity models and then road indices so that we could compare the different metrics to each other. And then we actually reviewed these indices, we developed a prioritization tool with the different metrics, so you could weigh ecological connectivity higher than motorist safety, you could weigh motorist safety higher than wildlife connectivity, depending on the question that you had. And then we reviewed these indices with our stakeholder group and tried to prioritize them for decision-making actually at the regional scale. And then our hope is that this would be integrated into policy and planning. So these are the metrics that we developed. I don't want you to get too bogged down in the table, but the first series were for motorist safety. At the time, we used the RCMP data, which is quite common in Canada, to use RCMP-based collision data to understand where high AVCs are occurring. Alberta Transportation has since improved this system greatly through a new program called Alberta Wildlife Watch, which uses, has highway maintenance contractors and transportation staff and environmental staff that work for the government actually reporting their observations along the road network through a smartphone app. It's a really slick, impressive system, and it will enable them to systematically understand at the whole highway network in Alberta where they have the highest number of collisions occurring. So at the time we used the RCMP data, and we did the same thing. We created a metric or an index that looked at where we just have the highest number of collisions occurring along our road network in our study area. We also adjusted this for traffic volume. And the reason we did this is because we were trying to get at the per motorist individual safety risk. So if you imagine someone driving that kilometer of road, what is the actual risk of them having a collision with a wildlife? And if you adjust for traffic volume, you can understand where the actual individual risk, highest risk is, which might be important for transportation agencies to consider. For ecological connectivity, we used 4 functional connectivity models. Most of these had support or were already developed by other researchers. So we had a rattlesnake connectivity model that had been, that we used an RSF that was developed by Adam Martinson. For the grizzly bear connectivity model, we used Scott Nielsen's RSF as a starting point. Adam Ford built the mule deer connectivity model. And then for pronghorn, we used Dr. Andrew Jake's modeling. And so all of these functional connectivity models were flipped into road indices, and I'll show you that in a minute. And then we also had a structural connectivity model, so a species agnostic model. So what structurally is left for connections, and how does that, where do those connections occur along our road network? And so for those of you that are interested in connectivity modeling, we used Theobald's paper for where he generalized the resistance scores for land classifications. And we used ABMI's land cover and human footprint data for that. So once we had all these indices, we were able to then run them to look at different priorities depending on the questions that the stakeholders had. So I'm going to kind of combine the results and the lessons learned together, since this is quite a quick presentation. So the first thing that I think is really important is that provincial transportation and environmental departments have different mandates. Transportation is mandated to address motorist safety, but the environment departments are mandated to address healthy wildlife populations, of which we think ecological connectivity is a really important component. Both of these agencies can benefit from road mitigation. We feel that standardized road indices for animal vehicle collisions and connectivity enable the government to systematically identify road sections where mitigation can occur, and that it enables them to look at it at an operational scale. So they're making the decisions at the scale that they should be making decisions at, which is the provincial road network. These are what some of the indices look like. So we have the structural connectivity model on the top. As you're going from blue to yellow, yellow is better connectivity or an increase in connectivity value. And how we flip this into this road indice on the right, where you can see we're going from yellow to red now, where red represents a higher connectivity value on your highway, is we buffered this road and we took the average connectivity value per road section, so per kilometer section. So that's how we ended up flipping it to this. And I think you agree, if you're a transportation department, this is easier to look at and make decisions on than this is here. The rattlesnake one is below, just showing you the same thing. So these are the indices that we were using to help with develop our prioritization. So some of the lessons learned that I think are really important from a road ecology perspective are that road sections with the highest total animal vehicle collisions and the highest per motorist safety risk kind of exhibited moderate spatial overlap. And maybe this shouldn't be surprising when you think of the rural landscape and how often animals are going back and forth on these smaller roads. But if we look at here, we have the RCMP index just based on the highest collisions, and we can see around Calgary, around Lethbridge, Medicine Hat, and on our major roads is where we have our highest number of collisions occurring. If you normalize this for traffic volume, you start to get at where we have animals that maybe are just going back and forth all the time, and it's more of these rural roads, like look at Highway 22 here. So this is just a different way of looking at the same data If we compare these indices, so they're both indexes from 0 to 1, if you add them together, the values that are higher around 2 are where we have agreement between these two indices. And you can see spatially here down on the bottom right, the red shows you where there's a good alignment between individual motorist safety risk and high number of collisions. So it's just a different way that Alberta Transportation or agencies can think about their data. Similarly, road sections with high animal vehicle collisions and high structural connectivity value exhibited poor spatial overlap. So again, same type of process. We have the structural connectivity model here. Remember, that's species agnostic. We have the RCMP based road index here. When we sum them together, where we have the high values near 2 is where there's high spatial alignment. And perhaps this is the really key message for us as conservationists. This is where you have good alignment between your motorist safety risk and perhaps your ecological connectivity. And so as conservation organizations, these are the areas. Interestingly enough, this is where the overpass is being promoted. In Banff, there's work on Highway 3 down here, and this is where we're working on Pronghorn. So all of those areas where we are together working on these conservation efforts are popping up in this model. So some of the other lessons learned, I think we all know road mitigation is extremely costly and it needs to be really widespread. So we have this problem where the need is high in a lot of places and it's extremely costly. And so I think the prioritization and us thinking through how to prioritize is really important. Traditional approaches for planning for road mitigation tend to focus on where we have the highest number of animal vehicle collisions. And I think that makes sense to all of us because the purview is usually for the transportation department and they are mandated to address human safety. So we tend to focus on areas where we have a human safety issue. And we've just thrown through this project that we might be missing the opportunity to address really important areas for ecological connectivity for some of our key species. So this is the big take home message. I think transportation departments need to help out I think environmental departments, the onus is on them to help transportation understand where there's important areas on the landscape to maintain ecological connectivity and where those align with the mandate of Alberta Transportation or transportation departments in general. So I think that's the big take home message. We are looking, because these are connectivity models, we are looking at trying to validate them. We have a project right now for Pronghorn where we are developed a program called Pronghorn Crossing with Alberta Conservation Association and the National Wildlife Federation. And we are trying to determine or being able to compare this fine scale movement data at the road level with connectivity models and then where Alberta Transportation's AVC, high AVC clusters are occurring through their Alberta Wildlife Watch program. So trying to understand the alignment and what the recommendations would be for mitigation based on these 3 different types of data. So here's where I think one of the big challenges, and I think as conservation organizations and as agencies, we are failing to address how significant this is. And I'd love to hear if others think this is significant and what some of the solutions are. AVCs, animal vehicle collisions, is often driven by deer. That's what's causing these clusters of motorist safety. It's typically deer. Now, of course, there's other species that are involved in collisions, but the data is really, the clustering of the locations is driven by deer. Maintaining deer movement across a highway and improving motorist safety or reducing the risk to motorist safety can be achieved through rather small culverts and fencing. But maintaining a grizzly bear or a pronghorn movement across a road requires infrastructure of a different magnitude. We all know both pronghorn and grizzly bears prefer overpasses. The cost of an overpass compared to a smaller culvert is substantial. And so I think we need to understand who has the purview for road mitigation, where the funding is coming from, and what some of the barriers are to build this infrastructure for ecological connectivity. And I'm wondering, and I'd love to hear from the group, how do we close that gap or appreciate this challenge that our agencies are facing? That's me. Thank you so much. I'd just like to thank, this project was funded by both Alberta Transportation, Alberta Environment and Parks, as well as a lot of in-kind time from both agencies and the Calgary Foundation through the Galvin Family Fund. So thank you so much.
Thank you so much, Tracy. That was fantastic. And before I get into the chat questions, I just want to give an opportunity for people who may have a response to the question that you just posed at the end of your presentation. If folks want to turn their video on and unmute themselves or just verbally, share their thoughts or share them in the chat, feel free to do that. We do have some questions in the chat though, if people need a minute to consider this question. Okay, so we will jump into the chat first. Questions about the wildlife collision app, what the specific name is, and then also if there are any considerations to using a similar app for citizen science applications. For example, highway users being able to report near misses with wildlife.
Yeah, that's a great question. The Alberta app is called Alberta Wildlife Watch. It's managed by Alberta Transportation. It's a really impressive program, but it is for highway maintenance contractors and staff, government staff are using it. From a citizen science perspective, we do have a partnership project and built an app for the BC side with Widawai and WildSight called Roadwatch BC, but that program is finished, but the app is still there. So there are citizen science apps out there. Probably we also have the Pronghorn Crossing as a citizen science app. But they're very specific, trying to address very specific geographic areas so that we can collect a lot of data. I think I can talk further about this and I won't take up all the question time, but I think it's hard to do it at a provincial scale. And I think the real solution at a state and provincial scale is to have the agencies develop their own internal apps that are collecting it at the scale they need. I think it's hard to get citizens at a scale of a province or a state to collect enough information for it to be meaningful. So I think citizen science has a stronger role to play in like Pronghorn Crossing, just little areas of highway that you really need to know a lot about that you can get people engaged in and dedicated to. Just an opinion.
Awesome. And I see that Scott has his hand raised. So Scott, if you want to unmute yourself and ask your question or comment.
Sure. I was just wondering if you were talking with the Ministry of Transportation through all this, and just wondering if their overall approach to working with you, do you see that they are really starting to look for these bigger infrastructure projects as something that they're going to start incorporating, or is it something still way off in the distance that they think that they might, or that they need extra resources to do?
No, I mean, I'm so impressed with Alberta Transportation, to be honest. They're working on this two of the projects that both Widawai and Miistakis and other partners have spent years on, one on Highway 3 and underpass that we think is really important for multi-species connectivity, and one on Highway 1. They're moving forward with, and it's big infrastructure projects that are beyond the motorist safety issue. So we're seeing really great movement on this. I just think the onus is maybe on us to make it easier for them to prioritize, understanding how expensive these investments are that they're making. I think we're not going to get as many of these as we need. And so I think it's on us to help them understand where the most important areas are. So I don't know if anyone from Alberta Transportation is on the audience today, but sounds like it'd be great if they identified themselves and said hello if they were.
More questions coming in from the chat. Oh, I see Jodie is raising her hand. I'm gonna grab a chat question first, but get to that in a minute. A question about, was posted speed limit part of the AVC risk model? If so, was reducing speed limits considered as a possible mitigation?
No and no. No, we did not consider the speed limit at all. And I'm not actually up on where the research sits with speed limit. So that might be a question for somebody else.
Awesome. Jodie, did you have a question? Or I saw.
I was just going to offer that at the federal level right now, the government is considering moving forward with a connectivity program, and one of the recommendations coming to them from various sources is to, and this is ecological connectivity, is to ensure that there's enough money within the departments of transportation and that kind of funding, or all those funding buckets at the various levels to address this. So I think that's actually really promising and something that we should support.
Yeah, great point.
Yeah, and on the subject of funding, a few people in the chat are also interested about funding these projects, developing budgets and efforts to make this more affordable. And then there was also a question about insurance companies, that they may stand to save money with fewer AVCs, and whether those things could be connected.
Yeah, they're all good questions. Insurance works differently in Alberta than BC, for example, where BC has one insurance provider. We have many. We've tried, on the Alberta side anyway, we've tried quite hard to reach out to the insurance companies, and we haven't had success there, but that doesn't mean in the future you won't, or it's not a good idea. Yeah, I think the funding issue is really important because you're suddenly asking, in our case, the transportation department, who could address the issue at a much lower cost, to spend, I mean, I think I don't know what the overpass, Jodie, is it 14 million, the overpass along? No? Do you know how much it is?
Well, the previous ones were more in Banff, were somewhere around 4 million, I believe.
Yeah, now they're substantially higher, particularly if there's not a highway upgrade is one of the challenges. So what's really neat about Alberta is they're showing some mitigation without a highway upgrade. It's actually for the issue of wildlife, for motorist safety and for connectivity at the two sites that are active right now, but there's not a highway upgrade going on. So the cost is much higher. So I think we just have to be really thoughtful about that. As conservation people, we have to be very thoughtful and help identify where the really important areas are to invest in this type of infrastructure. And hopefully it's not just addressing a motorist safety issue. I mean, I know that's so important, but if we can align those things, then I think that could be really powerful.
I see that Chad Wilms has his hand raised. So Chad, if you want to unmute yourself, video.
Hi, Chad.
If you're
Hey, Tracy.
having a good
Great
hair day.
Yeah, thanks for that. I wonder if you could share some thoughts on interim measures that could be put in place more easily as you're looking at trying to build out proper corridors and the right infrastructure. Obviously, it's a huge investment to not only put in the infrastructure, long process to then also properly secure and manage the adjacent lands. I mean, as we're seeing with the Jim Prentice corridor, I mean, it's decades of work, and NCC, Miistakis has put in so much work into setting up that corridor. So what are your thoughts on what are some of the simpler steps that could be taken to start to manage for, both reducing or mitigating vehicle collisions, but starting to actually support creation of a corridor system for wildlife? Simpler steps, cheaper steps that can be done in advance of setting up the full-blown, multi-decadal system.
I think that's a really great question. I think it's somewhere we need to go and have more discussion on. And I'd like to open that up and see if there's other road ecologists on here, what they think the solutions are, because I'm a bit skeptical if you remove the people if you remove the two from each other, which is what this infrastructure does, seems to work really well. But I'm not up on, all the other types of smaller things like flashing road signs and animal detection systems. I mean, animal detection systems can also be expensive. I'm not up on kind of what the percent success is of those things at reducing or solving the problem. I think some of them are still up. I think we're still experimenting with them and seeing their effectiveness. But at the end of the day, the solution that we have discovered that seems to work is to remove the animals from the road surface. So I don't really have an answer to that. I think it's a really important question. And I think we have to start getting creative and thinking more about that. I also think we need more creativity in the design of these structures so they're not so expensive. And I know there's been some efforts through, Jodie, what is that?
ARC.
Thank you, Jodie. ARC. And I think we need more efforts like that to help us reduce the cost of these things. But I don't know if anyone else that's on today wants to weigh in on that. I'd love to hear what people thought.
Road signs have a zero impact on the change of driving behavior by speed. So in general, they're really low. The wildlife vehicle collision, sort of the alert systems are, again, they can have an impact. And I think I saw Renee on here. She might be, or Melly, sorry, on here, and she might be able to comment. But again, not great results. It's unfortunate, but I think you're right, Tracy. If you want to, create a solution, it's about physical barriers.
Awesome. And I'm getting questions in the chat about how to use the fancy raise your hand function. So to do that, you go to the participants, again, scroll your mouse to the bottom of the screen. You'll see something pops up that has participants and then 2 people, and then you click on that. And when you click on that, you will see that there are some options of like raise hand is one, and it's a blue hand. And if you click on that, you can raise your hand. But we are at our halfway point. So I'm going to have us shift gears and turn it over to Jodie. And if there is extra time at the end of the webinar, we will get to any unanswered questions, because I do see some questions here in the chat that we didn't get to. So thank you, everyone. And Jodie, hand it over to you.
Thank you very much. Natalie, can you put your thumb up if you can see this? Awesome. Love it when you can see it. Okay, so it is a pleasure and an honor to be able to talk to you all today. So thank you for being here. I'm just representing a huge group of people, co-authors, and hundreds, and I mean literally hundreds of other people who provided input into these IUCN guidelines for conserving connectivity through ecological corridors and networks. This is a really important piece because it is pushing the world towards standards. We know that corridors are important, but how do we achieve them has been a subject of a lot of debate. So I want to just frame this a little bit. The IUCN puts out a lot of different guidance and standard documents. For those of you who are younger, you might not know that protected areas were not always agreed upon at the global level. Thanks to the IUCN and the work that they did, they got global agreement of what a protected area is, whether you're in a marine protected area in Belize or a terrestrial protected area in Nepal. They fit a set of concrete, tangible, measurable guidelines. This is where we're working on getting going on ecological connectivity, and this document takes us a long way towards doing this. If you're not familiar with IUCN, it is the largest nonprofit in the world. It has 1,400 members, 15,000 experts, and within the small arena of the World Commission on Protected Areas, under which this connectivity specialist group sits, it has 2,500 members from 140 different countries. It is largely volunteer driven. So let's get to the connectivity guidelines. Things like defining connectivity or ecological corridors take a long time. And this certainly is the case in terms of corridors. For the IUCN, I mean, certainly it was a subject in science for much longer, but people started gathering and talking about connectivity and actually through the Mountains group originally. And these meetings went on and on and on. And in 2016 in Hawaii at the World Conservation Congress, there was an agreement that we needed to have these guidelines. The chair of the IUCN Connectivity Specialist Group, a guy named Gary Tabor, facilitated global consultations to happen literally around the world to try to get input, because this is about everybody coming to global agreements on documents. And if you know scientists or you are a scientist, you know how hard that is to actually get to agreement. Plus you're dealing with policy, lawyers, and other people. So ultimately there were 16 core authors. There were 38 case study authors. There were lots and lots of individual formal, informal reviews, plus the consultations. And so there was a lot of input into this globally agreed upon document. So this document has 3 purposes. The first one is really not new, but it's important, which is about consolidating the wealth of knowledge and the best available practices. That's been done a lot, but it's always important in these kinds of documents to make sure that you have that represented. What's really new is that we're advancing the guidelines, like very specific, concrete on what a corridor is and what it's not. And then the third piece, which is in development right now, is getting the world database on protected areas to begin tracking where there are conserved ecological corridors. Today, certainly in North America, let alone the rest of the world, we actually don't know where connectivity, we know where connectivity might be from a structural perspective, and I'll talk about that, but we don't actually know where it's conserved. It might disappear tomorrow from places that currently have connectivity. So I'm not going to go into chapters 1 and 2, other than to say that this sort of sets that stage of why we need connectivity. It is my assumption that everybody on this phone call knows these things: species at risk, human footprint expanding, climate change, etc., and that protected areas aren't going to function unless they're connected. So if you want more information about that, I'm happy to send you the guidelines, send you corridor ecology or whatever, but I'm not going to get into this. And then likewise, we had to set a basis for scientific connectivity. Again, I think most of you are pretty familiar with this, but again, I'm happy to be a resource for that. It all started in sort of conservation biology, things like island biogeography and metapopulation theories, and that connecting small isolated populations can retain populations across the landscape. So again, not going into that, but here's where it starts to get interesting. If you map out, as we did here, the growth in protected area coverage, we can see that actually there's a reason to feel optimistic. We are going the right direction, maybe not in the States, but generally speaking, things are going up. And what's really exciting to me, given that most of the world is marine, is how much the marine protected areas have increased. But over here on the left, you can look at the Sara et al. Paper and some other papers that have come out. About 10% of the terrestrial realm of looking at that structural connectivity modeling that Tracy talked about is actually still connected. It's still connected, but we don't know if those areas that are structurally intact, that are serving that connectivity, are A, functioning, and B, we don't know if they're actually protected. Are we going to lose that connectivity soon? So that's a big concern. I want to pause here and say that a big part of the multi-year process of doing this, and why I now have some gray hairs popping up that my daughter tries to pluck occasionally, is getting to a common language and an agreement. And again, this goes back to scientists being really picky and lawyers being really picky about words. And it is important to be picky about words. So I'm just going to say a few things. One is, for example, I made 3 trips to the United Nations Convention for Migratory Species with others from the IUCN Connectivity Specialist Group to get to an agreement on the definition of connectivity. As you can imagine, the United Nations Convention for Migratory Species really cares, as does the specialist groups. So we came up with a definition up in the upper left-hand corner. That does not suffice for the scientists. So what we had to do is say, here is the policy definition, and underneath that is the science definition that includes these things like genes and propagules and other things that scientists really want to make sure is in there, so that everybody can see themselves in this document. That was really important. Another issue is, what is an ecological corridor compared to a protected area, or this thing called other effective conservation measures, or OECMs, which I won't get into, but if you want to know about them, call me some other time. So the question was, is, for example, the Yellowstone to Yukon, is it a corridor? Would it be inclusive of the protected areas and the stuff in between or not? And the answer was no. And then there was the question was, well, this new thing called OECMs, couldn't that serve for connectivity? And again, the answer is no. Why? Because both protected areas and OECMs have to conserve biodiversity. corridors can conserve biodiversity and often do, but they also might be, there are certain levels of human use, right? And so the prime purpose is not conservation of biodiversity, but rather connectivity. Protected areas and OECMs can wholly or partly contribute to connectivity, let's say of a migratory pronghorn, but it is not their mandate. Whereas for ecological corridors, we have to define what connectivity it is achieving. So of course, ecological corridors aren't adequate unless we look at the sort of larger scale. So a corridor to nowhere does nothing, but it's about, like this Western Thailand case shows, making sure there's connectivity between protected areas and OECMs, protecting what to what. And so there was already work done by the United Nations on this, and we then sort of took that and and brought it into this document to make sure that the three components, or the three legs of the stool, protected areas, OECMs, and protected areas, are all clearly defined in that context of an ecological network for conservation. And this is the messy reality, the best that we could do, where the green and the blue areas are protected areas, and then these OECMs are in brown, and you can have stepping stone corridors, ecological corridors, you can have continuous corridors, they can function at different scales for migratory species that fly, for terrestrial species, for movement over generations, you name it. So this is where it gets exciting. So then it's, what is an ecological corridor? If you're a scientist, you say, well, there's the matrix, and the matrix just needs to be permeable. Well, the matrix is changing all the time. So how do we ensure that we pick a place that is climate resilient and that can ensure connectivity for species that are identified really clearly? So it's about actually saying, this is the space that's going to matter now and forever. Here's what's allowed and what's not allowed, what's going to interfere with that goal of connectivity, whatever it is. Here are the legal mechanisms that ensure that this corridor is going to stay that way for the long term. And here's the required monitoring, evaluation, and reporting. So I want to remind you of a couple of the fundamental principles. Those corridors are between, but do not include protected areas or OECM. So you could have, several elements or several disconnected pieces that are all being managed under the same governance that could be, grouped as ecological corridors, or they might just be distinct segments. They could be huge, they could be short. They have to have really clear ecological objectives and be governed and managed clearly for the long term for those purposes. Again, ecological corridors could be totally natural, or they could have human activities, but then we have to define what are those compatible human activities. Sometimes it's, time issues, that this can happen at a certain time, but not another time. Sometimes it's, you can never put impermeable fences across a corridor, etc. So it's really about being clear about these things. Again, I want to emphasize that it's really clear that to get to a corridor that could be designated in the Protected Area Planet database, it's for the long term and through clear mechanisms. We recognize in there that perhaps ideally different jurisdictions, so we see some urban areas have corridor legislation, like where I sit in Canmore. Some states like California have corridor legislation. I mentioned that Canada is considering having a federal level ecological corridor system. And for years now, I think it's going on 6 years, the federal level of the US has been considering corridor legislation. But short of all that stuff happening, which is the best thing and the easiest way to go forward to support corridors, there are lots of other tools that we can use in the meantime, certainly in North America, but also around the world. So the other important thing I mentioned, protected areas, and it was a fight, are the same. They fall under the same definition for marine and freshwater and terrestrial, and so does connectivity. And that was, again, it was a real struggle because marine is so cool. They have like vertical corridors, which I love. Airspaces, we mentioned, there just isn't enough research out there, and there certainly isn't the legal arena right now that's well enough to develop to actually create a continuous airspace corridor, but the idea is there. And most importantly, for corridors is often those mixed places. We might have a marine protected area and a terrestrial protected area, but they need to be connected across those arenas. So law and policy is an important part of this. And we would argue that connectivity actually is a requirement to achieve many of the global conventions and agreements. And actually many places are moving forward with this different kind of legislation, and I mentioned some of them. But here is just a partial list of the many international instruments and bodies, many of which are signed by one or both countries, that really to achieve these requires addressing connectivity. But the mechanisms for doing that really haven't been as clear as they need to be. And I mentioned that a lot of entities are moving forward. Bhutan is always my inspiration. Because of gross national happiness, they realized that nature was important, and they saved 53% of it, and of course connected them as they should. Costa Rica is not far behind with a major network that's connected and protected, and many other countries are moving forward. So I mentioned the last piece, we're right now really trying to support the Protected Planet World Database on protected areas. They're writing up the framework for how to begin reporting ecological corridors, which is really exciting, and will help us as scientists actually understand what is protected and connected versus what is protected but at risk, or connected but at risk. I'll just mention, I'm not going to go into them, but there are case studies, marine, freshwater, and terrestrial from around the world. And I think they're really instructive, and they're sort of where different efforts are at towards achieving connectivity and how that can kind of feed into formalized ecological corridors. Overall, we know that if we can, create ecological networks, including functional and conserved ecological corridors, that this will address a lot of our issues around biodiversity and conservation, as well as social and economic challenges. So I'm gonna stop there, say thank you to the many people who contributed, to the many funders who helped make this possible. It was really a big lift. The Center for Large Landscape Conservation was really the bedrock organization that ensured that this could keep going. So thank you to them. And if you have questions, I guess say that I prefer to see you and have the questions otherwise. And I do want to mention, Natalie, if there's interest, I did pull some slides that actually show some of the historical connectivity research that has been done in the Crown of the Continent, and I have no idea whether you all have seen that or heard that, but I'm happy to share them if folks are interested in it and we have time.
Yeah, that would be fantastic. And if we don't get to that, that would be a great thing that I could add to the follow-up email that I'll send out to all that are registered. So anyone have any questions for Jodie? I see Sean Finn has raised his hand first. So Sean, go ahead and unmute yourself, video on if you are ready to ask your question.
You all can put your videos on.
Video, there we go. Thank you, respecting your request, Jodie. Thanks for that great presentation, and I would love to see that summary and photography. Thanks very much.
I think Sean was frozen a little bit, but I think he said he would like to see that list of resources, so that's great.
Okay, it's actually sort of a PowerPoint discussion, but I can still send it, yeah.
Awesome. I see Anne Carlson has her hand raised.
Hi, thanks so much again to both you and Tracy. Always fantastic to hear you give presentations, and so appreciate it. I guess I had a question actually for both of you. Because the climate is changing, we're seeing a lot of flux and variability in the.
Oh no, you went out. You froze, Anne. Anne, you're frozen. Shoot. I think we're gonna have to go on.
Well, maybe while we're pausing, waiting for Anne's internet, and there's also a phone number too that folks can call into in their Zoom if your internet is unstable. And I see Scott has his hand raised, so maybe we'll pause Anne's question and ask
Natalie,
Scott.
can you hear me?
Oh, now we can hear Anne. Sorry, Scott. And
I'm sorry. Forgive me.
Is
So
your
Anne, you
internet good
froze,
to go?
totally.
Oh, okay. Well, I just took my video off. I'm sorry about that. I guess I was just wondering, because of the variability in the way that animals are moving across the landscape in response to changing climatic conditions, and the way that the variability from year to year in the weather is become much unpredictable. There are large-scale changes in corridors and where they are and who's using them over time. How do we really think about addressing these major challenges? Because it takes so many years often to designate or a corridor, or to come up with a wildlife crossing, for example.
Yeah, I think particularly in the Crown of the Continent region, we actually don't have that many opportunities to conserve open spaces and to even connect the remaining places. So I think a lot of that is sort of foregone, and it's about finding the best of the last. But also, I would say, we ran a few years ago, and Anne, you might have been part of them, I'm not sure, through Molly Cross, we ran some analyses or workshops with the wolverine and the grizzly bear folks, looking at connectivity in the lower 48 states of the the Yellowstone to Yukon region. And basically, the feeling was that these animals are largely using riparian corridors, and that's going to be the best approach as some of these places get hotter and drier in the future. But I think thinking through that and making sure as corridors get selected that they are more likely to be robust, or they're the best of the last or the only last, is an important process to try to ensure that things are, that we're selecting places that might be enduring from a connectivity. I don't know if that's helpful.
Thanks. Scott?
Sure. My question was just, I wonder if you could just elaborate a bit about the federal government coming up with connectivity to support connectivity across Canada. What have you heard? Like, what do you think that they're proposing?
Yeah, well, I think they're very much in a listening phase. So I sit on a committee that is providing some advice and offering some suggestions right now, and there are other groups that are doing the same thing. So I don't think that there's a commitment per se, but it is very much part of my committee is part of Canada Target 1. And in order for them to achieve Canada Target 1, which Trudeau has been very clear continues to be a priority, he's now promoting 25 by 25, that connectivity is a very explicit part of that. So I think hopefully we'll be able to hear something in the next couple of months that's more concrete. Yeah.
We have a question in the chat. Can you talk a little bit about what you think are the most exciting ongoing science research in connectivity in Y2Y?
Ooh, well, I think this is looking backwards a little bit, but I think one of the coolest pieces, and I'm going to focus on Crown of the Continent for a second, is a very recent paper that came out from Michael Proctor, maybe I think last year, that I just think it's so cool. So this collaborative, this Cabinet Purcell group came together. Scientists like Michael Proctor and Chris Servine sort of said, here's the best available science on what we need to do to try to take what are these really small isolated populations of grizzly bears and try to make sure they don't blink out and go extinct, including connectivity. And so literally 60 different groups have been doing work on trying to secure core areas, actually purchasing or putting easements on private lands. In fact, there's one going forward this month in that same region, which is super exciting. And doing a lot of coexistence work. And what Michael Proctor then published was they were continued following grizzly bears. And these grizzly bears that were isolated all of a sudden started to move across some of the very corridors that were protected. The overall coexistence measures, like, even though the numbers of grizzly bears have gone up in some of these places, the overall conflict has been lower. And I just think that that's a really neat use of the beginning of science to the end of science, sort of the monitoring from where we need to get the work done to the evaluation of whether the work getting done is actually having an impact. And I just think it's so inspiring and uplifting to see. Science though.
Yeah, that sounds amazing. Any other questions for Jodie? Either type them into the chat or feel free to raise your hand. If
And
nobody
also
else.
put the other too.
Yeah. I think maybe that might be the way to go. I'm seeing thumbs up from folks that are like, yes, please. So I think that might be a good next thing to do.
Let me go back. Oops, wait, I think I just turned it on my slide, but not yours. Okay, I'm gonna do that. Share. All right, so, whoops. I'm just going to quickly run through this and maybe make you dizzy doing it. So for those of you who are newer to this landscape, I want to remind you of some of the different connectivity things that have been done. This was led by Clayton Apps, John Weaver, and Paul Paquette. And I didn't include that John Weaver did a transboundary assessment of just the Flathead region, which is, again, one of the, and again, I think it was a WCS Canada working paper, but was the first that we realized that that's the place that has the most carnivores of anywhere in the Y2Y region. This is specific to connectivity, really, really good piece. And again, it's so old that some of you might not know about it, but it stands. This is some of the work that came out of this on where connectivity specific to the highway needed to be. And I didn't include the Miistakis work, but again, if you were to, because I thought Tracy was going to include it, sorry Tracy, but if you were to compare some of these models, what's really great and what you want to see in science is that the research corroborates on the important areas. And if you look at the Wild Site BC data, again, it further corroborates it. You can, of course, look at this from a global scale, like the human footprint analysis, and really see particularly the Highway 3 area that is getting severed.
No.
You can also look at this from what that Tony Clevenger et al.'s work has done, looking at here's where wolverines are doing well, here's where they're doing well, but there's a collapse in the middle. And I will say Tony, Mike Sawaya, Clayton Lamb, and I might be missing others, are looking at some new connectivity work, particularly as this area is looking to get developed. The story is the same for mountain goat populations, again, crashing except for in the roadless areas. And so we really start to see that there's been a lot of research, and grizzly bears, I mentioned before, but again, very much collapsing in that southern Alberta area. And I think this really says it all, how isolated some of these populations were. Some of them are beginning to recover. You know, Michael Proctor's connectivity work, again, very focused on grizzly bears, again, shows this connectivity across, and this is very specific to Highway 3, but his work goes beyond that. This is just what I had easily to show you all. And again, the places that are coming out come out over and over and over again. So I just wanted you to be aware there's lots of research there at different scales on connectivity. And I'm happy to point people to that, to where to get those pieces of information. But I think what's most hopeful for that is probably one of the most better studied areas from a connectivity perspective. And what's most hopeful is that when you overlay that different science, even though it's at different scales, it kind of ends up pointing to the same priority areas over and over again. So we're kind of clear that we're on the right track in terms of our priorities. Questions on that? We have time?
Yeah, we have time for a quick question on that. And yeah, thank you for providing that insight. It's really cool to see all of the amazing science that is overlapping and working in unison. So thank you. Any questions for Jodie about that? Scott?
Sure. So do you have actually a link to this research? Like, do you have a file folder, or is it, would you have to actually dig for it? Like, is there one source that we could go to?
Yeah, you know what? I think I can get you, like, I think I can dump it for you. Actually, one of my colleagues pulled it together, so I need to confirm that. But we'd be thrilled to provide it for you. Scott, can you email me so that I can it's jodie@y2y.net, Jodi.
Okay.
And then I can get it to you, or I can get it to Natalie and she can share it, whatever's best there.
Thank you.
Awesome. Well, we are nearing the top of the hour. I want to thank both of our speakers so much for taking the time today to share all of their insight and knowledge with us. And thank you all for being here today to learn with us. And shameless plug for our Fire Forum, the Crown Managers Partnership Fire Forum has an official set of dates. It will be the week of March 22nd through the 26th. Agenda and specific timing is forthcoming, but make sure to block that out on your calendars. It will be virtual. So thank you all for being here with us today, and have a great rest of your day, and happy holidays.
Thank you.
Thank you.
Thanks for all you guys do. Happy holidays.